Day 271 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem, and this time we're at day 271 and we're still going strong doing daily LeetCode problems. And today we have question number 4, medium of two sorted arrays. The difficulty level is medium, but don't worry because we're going to keep the solution as simple and easy to understand as possible, y'all. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check that link out in the description. Now, let's see what the question says. Question says, given two sorted arrays nums1 and nums2 of size m and n, respectively, return the median of the two sorted arrays. The overall runtime complexity should be big O of log m plus n. So, sounds simple enough, but let's look at the examples just to make sure we know what it is exactly that they want us to do. So in example 1, we have the input nums1 equals an array of integers 1 and 3. Nums2 equals an integer of 2. The output is 2. Explanation says when you merge these two arrays into an array of integers 1, 2, and 3, the median is 2. So as you can see, the median of this array is 2 because 2 is the value that is in the middle of the array. So let's look at example 2 where it might be a little bit more tricky because there will be an even number of elements, which will make the median a little bit harder to find, right? But still simple though. But let's look at it anyway. In example 2, we have the input nums1 equals an array of integers 1 and 2, nums2 equals an array of integers 3 and 4. This time the output is 2.5. Explanation says the merged array equals an array of integers 1, 2, 3, and 4, and the median would be 2 plus 3 divided by 2, which will give us 2.5. So let's just break that down one more time. Let's go through it so we can understand what a median is, and we can make sure we understand that before we move into the solution, because that's the important part, right? So the median is just the middle value in a list of numbers, right? But when we come to a list of numbers that has an even amount of numbers, right? So up here in example 1, it's easy to find a middle number because it's an odd number of elements, right? So we know 2 is in the middle because there's 1 on this side, there's 1 element on the left, and there's 1 element on the right. Now when we look at example 2 and we're dealing with an even amount of elements, it might be a little bit more tricky, right? Because you might not know if the 2 is in the middle or the 3 is in the middle, right? So what you do to handle a case like this, you take the two middle numbers, right? Because these are the two middle numbers. As you can see, it's 1 element on this side of these two numbers, and it's 1 element on this side, on the right side of these two numbers. So these two are the middle numbers. We take these two middle numbers, right? This 2 and the 3, we add them together, and then we find the average of those, or we just divide it by 2, right? So we take the 2 plus 3, we divide that by 2, boom. And then that gives us 2.5, and that's how we get the median, 2.5, which is our output. So we just take the two middle numbers, add them together, divide it by 2, and whatever that is, that'll give us the median, right? For example 2, when we're dealing with an even amount of elements. So now that we understand the question, y'all, let's get into the fun part, the actual solution. Solution's not that difficult, as you already may have assumed, so let's get into it. So the first thing we're going to do is we're just going to check to see if nums1 is a smaller array, which will help us optimize in our binary search. If nums1 is larger, then we're going to swap the arrays and we're just going to call the function again. So in order to do that, we're just going to come right here and we're going to say if nums1.count is greater than nums2.count, boom. Then we're going to open up the brackets and we're just going to say return. We're going to use some recursion. We're going to call this function find right here. So we're going to say return find median sorted arrays. Open up the parentheses and we're just going to pass in nums2 comma nums1, just like that. Now we need to declare the length of the input arrays. So we're going to come right here and we're just going to say let, open up the parentheses, m comma n equal, open up the parentheses, nums1.count comma, nums2.count. Boom, just like that. Then we need to set our binary search boundaries within nums1. So in order to do that, we could just declare a variable, open up the parentheses, say L, comma, R, come outside of that, we can say equals, open up the parentheses, 0, comma, M. Boom, just like that. Now let's get started with our binary search. We're going to start with the while loop. We're going to say while L is less than or equal to R. We'll open up the brackets. First thing we need to do is we need to partition the index for nums1, right? So find the midpoint for the binary search. So in order to do that, we're just going to say let I equal, open up the parentheses, L plus R, come outside that, divided by 2. And that's just going to find the midpoint for us. Now we need to partition the index for nums2, ensuring that the left and right halves are balanced. So in order to do that, we're going to come right here. We're going to say let J equal, open up the parentheses, M plus N plus 1, and then we're going to come outside that, and we're going to divide that by 2 minus I. Boom. Now we need to create the edge cases for if the partition is at the boundary, we're going to use the min and max values. So in order to do that, we're going to say let max left, let's clean this, keep these together. Let max left A equal, open up the parentheses, I equal sign 0. So this equal sign is going to return a Boolean, true or false. So if I is equal to 0, so we're going to come outside, say question mark. If I is equal to 0, we're going to say int dot min. Otherwise, we're going to say colon nums1, open up the square brackets, I minus 1. And that's going to be the left max of nums1. Now, we need to declare another variable. We're going to say let right, not right, but let min right A equal, open up the parentheses, I equals M, come outside of that question mark, we're going to say int dot max. This time, then we're going to say colon nums1 square bracket I, just like that. Boom. Then, this should be int max, not n max. Int max, boom, just like that. Boom. Now we're going to say let max left B equal, open up the parentheses, we're going to say J equals 0, come outside of that question mark. This time we're going to say int dot min, then we're going to say colon, and this time we're going to say nums2 square bracket J minus 1. And what that's going to do, that's the left max of nums2. So this is the left max of nums1. This is the right min of nums1. This is going to be the left max of nums2. Now we're going to do the right min of nums2. So in order to do that, we're going to say let min right B equal, open up the parentheses, J equal sign N, this time N, then come outside of that question mark, we're going to say int dot max. Then we'll say colon, we're going to say nums2 square bracket J. Boom. Now we need to check if the partitioning is correct. So in order to do that, we're going to say if max left A is less than or equal to min right B, and max left B is less than or equal to min, min right A, then we can open up the brackets. Boom. Now, if the total length is even, we need to return the average of the middle two values. So in order to do that, that's like if we handled this case in example 2. So in order to do that, we're going to say if, open up the parentheses, m plus n mod 2 equals 0. So if it's even, what we're going to do is we're going to say return. Then we're going to open up the parentheses. It's going to be a double. So we're going to say double, open up the parentheses again. We're going to say max, open up the parentheses again. We're going to say max, max left A, comma, max left B. Then we're going to come outside of these two parentheses, but still inside the last parenthesis, and we are going to say plus double, open, y'all, it should be double, open up the parentheses, min, open up the parentheses, min, right, right A, comma, min, right B. Then we're going to come outside of these three parentheses and we're going to divide it all by 2, just like that. Boom. Then we're going to come to outside of this if statement, we're going to say else right here. So now we're dealing with the odd number. So if the total length is odd, we need to return the max of the left partition. So in order to do that, we could just say return double, open up the parentheses, max, open up the parentheses, max left A, comma, max left B, just like that. Now we're going to come to outside of this if statement right here, right? And we're going to then we're going to say else if max left A is greater than min right B. We're going to open up the brackets, and we need to see if the left max nums is too big, then we need to move the partition to the left. So we're going to say R equals I minus 1. Otherwise, we need to move the partition to the right. So we're just going to come right here. We're going to say else, open up the brackets, L equals I plus 1. Boom. And then we could just come down here and we could just return 0.0, even though we should never reach this value if the inputs are valid. So that should be all she wrote, y'all. So go ahead and run it. Hopefully it runs first try. Let's see. Okay, we have an error. We have an error right here. So let's see what it says. Separator. Oh, hold on. Can I find left max and right max? Hold on. So let's. Seems we got a lot going on here, right? So we cannot find left. Oh, so this right here shouldn't be a space. Let's run it this time. See if that works. Okay, cannot find min right. Okay, we got it. That should be a lowercase I. Let's run it again. We're getting closer. We're getting closer. Wrong answer. Okay. So once again, if you get the wrong answer, 9 times out of 10, the math is off somewhere. Now, as you can see, there's a lot of math in this problem. So we got to go through this step by step and make sure that our math is correct. Oh, and right here, this should be 2 minus I, not 2 minus 1. So let's run it again. Let's see. Hopefully that works. Let's see. And that's accepted, y'all. That's what I'm talking about. So let's go ahead and submit it. Make sure it's still accepted after we submit it. So let's see. Fingers crossed. Ooh, look at that, y'all. 0 milliseconds beats 100% of users with Swift. That's what I'm talking about. Those are the numbers I like to see. So before we leave, y'all, make sure you get one more look at the code. Get one more look at the code. It's the top half of the code. Now let's go ahead and let you get the bottom half. That's the bottom half of the code. Now go ahead, read it, learn it, love it, do what you have to do so you internalize it and understand it. And I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.